In a multi-cloud world, control is everything. It's the name of the game. So today, we're going to build the blueprint for a secure, automated lifecycle for your container images, one that guarantees consistency no matter where your code actually runs. So let's get right to it. If you're a senior architect, this question probably keeps you up at night. When your services are spread across ECR, ACR, and Google's Artifact Registry, how do you truly know that the code you tested is the exact code that's running everywhere, every single time? The dream scenario here, and what we're mapping out today, is moving from total chaos to complete control. The goal is one single automated pipeline, a kind of golden path that every container image has to follow, ensuring security and consistency from the second a developer hits commit all the way to a global production rollout. The solution to this whole puzzle has a name: the image promotion lifecycle. Now, this isn't just about moving files around. It's a formal, standardized workflow. Think of it as a series of automated gates for validating, tagging, and, this is the most important part, moving the exact same digital artifact from dev through staging and finally into production. Okay, so to really get this, let's follow the journey of one single image and see how this all works in practice. It all starts right here at the very beginning, the birth of the image, from a simple code commit to its first home in the development registry. This first part, it's all about speed, pure automation. A developer commits their code. Immediately, the continuous integration pipeline kicks in, builds the container image from the Docker file, and just like that, boom, the brand new image is pushed to your dev registry. This is the raw material for everything that comes next. Now, here's the really clever part. Look at the first tag we apply. We're not using latest or some random version number. No way. The tag is the git commit hash. This creates an unbreakable link, an immutable identity that ties this specific binary artifact directly back to the exact line of code that created it. Traceability is absolutely everything here. So, our image exists. But is it any good? Now it has to prove itself. It's about to enter the next stage, what I like to call the gauntlet, the staging and scanning phase. This is where the image goes from just being built to being trusted. Getting into staging isn't just one step. It's a really deliberate three-part process. First, we copy the image using its commit hash. We never, ever rebuild it. Second, it gets deployed into a staging environment where we run all our integration tests to make sure it plays nicely with other services. And third, the automated security scanners get to work, picking it apart to look for any flaws. So what are we actually looking for when we say scanning? Well, it's not just some magic black box. Our automated gatekeepers are hunting for known vulnerabilities, or CVEs. They're sniffing out accidentally committed secrets, like API keys. They're making sure all the software licenses inside are compliant, and they're checking that the image follows our own internal policies. If it fails even one of these checks, it stops dead in its tracks. Okay, so after passing every single test and every scan, our image reaches its crowning achievement. It is now officially certified as production ready. This is the final step in its journey, where we get it ready for its ultimate destination. And the best part, the approval is totally automatic once all those checks are green. The verified image is then copied, again using its unique hash, into the highly secured access-controlled production registry. Only now, at the very end of this entire journey, does it finally earn its official human-readable production tag. This table right here lays out the whole strategy perfectly. Just look. In both the development and staging environments, the image is always identified by that unchangeable commit hash. It's only when it's been fully vetted and promoted to production that we apply a stable semantic version tag, like v1.2.5. This tells the operators exactly what release they're about to deploy. No guesswork. Okay, listen up, because if you take away only one thing from this, let it be this. You copy, you never, ever rebuild. Why? Because when you rebuild, you introduce variables. Maybe a build agent has a different OS patch, or a base image got updated. Those tiny differences, that's where the nightmare bugs that only show up in production come from. Copying ensures the exact same collection of bits that passed all your tests is what you deploy to your customers, period. You might think we're done once the image is deployed, right? Wrong. The journey doesn't actually end there. There's a final, critical chapter that so many people forget: cleanup. And this is absolutely essential for keeping your system healthy, secure, and cost-effective in the long run. So why even bother with cleanup? Isn't storage cheap? Well, for one, It saves real money on cloud storage costs, and that adds up fast. More importantly, you're shrinking your attack surface by deleting old images with unpatched vulnerabilities. It also prevents engineers from accidentally deploying some old, crusty version, and frankly, it just keeps your registries clean and easy to navigate. When you put it all together, what we're really talking about is a total transformation. This slide just says it all. You're consciously moving away from a world of chaos, with its inconsistent builds, manual errors, and security holes, to a world of control. One where you have an automated lifecycle, immutable artifacts you can actually trust, clear tagging, and security scanning that's enforced, not just a suggestion. So let's boil it all down. If there's one single idea to walk away with, it's this. The entire system we've just designed comes down to the power of one standardized workflow. That is the key that unlocks control, consistency, and predictability, whether your infrastructure is on AWS, Azure, Google Cloud, or all three at once. And there you have it, our blueprint for a multi-cloud image promotion lifecycle. So, I'll leave you with this question to chew on. Your production environment is your kingdom. Looking at your current process, how strong are the gates you've actually built to protect it?